week, we had two folks on being Labor Day. We didn't have as many people on, and one of the guys said that he really wanted to see kind of failure mechanisms related to different structures. So this was our first week on it. The guy that actually requested it isn't on the line anyways, but we'll go through it this week and see where it's at. And this is going to talk. We're going to talk about cross-vane structure analysis and kind of where we see failures and what are some resources for that as well. I did send out a PDF today of a document from Virginia Tech University where Tess Thompson ended up putting together a fact sheet on cross-vane structures, and it talks a little bit about failure analysis. And they used information from Barbara Dahl and Paige Puckett at NC State years ago to come up with failure analysis of structures. So where did a cross-vane come from? Originally, a cross-vane came from the idea of a check dam. Dave Rosgan, Lee Sylvie, and others. Lee had just passed away last week, but while working at the Forest Service, people started seeing these cross-vanes, and these check dams, and these check dams, you know, from the 50s through the 80s, and even still today, were installed to slow down water, to slow down velocities, to catch sediment, but they saw a lot of failures in these perpendicular cross-channel structures. So Dave and Lee and some others started coming up with ideas of vortex weirs. And this was a weir that would concentrate the flow as a V, and it would turn water from the banks towards the middle of the channel so that you wouldn't see failures on the edges of these structures as they tied into the banks that you would on a perpendicular structure. And vortex weirs were created to reduce bank shear forces, centralized flow. They were also going to create some sort of fish habitat and allow for fish passage. Eventually, the structures adjusted, the throats were opened, the slopes of the arms were slightly adjusted, and they were created as more of a continuous structure on the arms opposed to gaps in the arms. And the Boulder cross-vane was created in the late 90s, and this was directing flows into a new channel alignment. It would also be grade control and create scour for pools and habitat, and then we'd have footers and boulders and geotextile that were involved in the design of these processes. This is a project North State Environmental worked on in Swannanoa with Grant Ginn and Wolf Creek Environmental a number of years back. And this is a big cross-vane that was being installed, and you can see how the rocks are placed and it centralizes flow. So with this, we create details. Details through River Shared, we're trying to create details that will be available for people, both in AutoCAD and PDF, so people can use them. We're trying to figure out how we're going to create them in such a way that they can be used, but yet it doesn't pass on liability to people because every structure slightly changes. So we're thinking about creating them with dynamic things that require that you add information into certain blocks, or else they won't really work for you. So this is the current detail. This was borrowed from a company called WWC out of Laramie, Wyoming. And right now, the current status is that you create a sill that ties into the banks. And then as that sill ties into the banks, you have a vane arm that goes about a third of the way into the channel. That vane arm goes at 2 to 5% vane slope based on the material that's in there. And then you have a proposed throat of the vane, which goes across the middle third of the channel. And then you have your next vane arm, and then it sills into the channel again. And you can create a cross vane with a step on it, like this is shown here, or you can create a cross vane without a step on it. So these are a couple different things we look at. We have a horizontal angle, which is related to 20 to 30 degrees from the bank, and you have a vertical angle on the arms, which is 2 to 5%. Now all these angles have adjusted. Originally, when I started in the field in the late 90s, we were calling for 10% vane arms, and they were to tie into at the bank full slope, whereas now we're calling them to tie in below the bank full slope or bank full elevation. Even the placement of the boulders, we end up putting details on there to show a slight tilt in the upstream direction so that these rocks kind of push the next footer rock into the ground instead of just sliding off like a sliding board. So there's a number of things that we look at, but the concept is that we put in a vein. We don't want to protrude a whole lot above the bed of the channel. We want to get some bank protection upstream, and we want it to centralize flows, create a habitat downstream. So if you put in a second drop, it generally allows you to have less drop over the structure, so you can improve fish habitat, also improve some stability in the structure as well. So here's a double drop, and you can see water at higher flows dropping over each one of them. You still have the water that gets turned over the cross vane itself, but then the drop ends up not really centralizing the flows too much. So a cross vane double drop, you'll go about 5% slope at 25-degree angles. This is the project we built in Tahlequah, Oklahoma years ago with Moore State Environmental and Greg Jennings. And we ended up taking a half-foot drop over each structure here. A lot of times we will design our drop over our structures based on the boulder diameters we have available in the scour depths. So we look at things like going 2 times the potential scour depth as being how much, as being what we can protect against. So if we look at a scour potential of 1 foot, then we're going to look for a footer depth of 2 to 2.5 foot if our maximum scour depth is 1 foot. So then if we have a scour depth of 1 foot, we probably want to make a drop height of about 1/2 foot if we don't have fish passage concerns. If we have fish passage concerns, then we have to limit our drop height. And a lot of this is related to what we're using, whether it's a boulder or rock for grade control. So we moved to a situation where vortex weirs, we used to place them inside a river, and they would sit on top of the riverbed like a cheese grater. So you have a cross section, then you put the vortex weirs on top of them. We've moved to a point where the cross section of these structures really represent the cross section of the riffle or the pool. We don't protrude above the bed of that cross section anymore. Now we do have a drop right downstream of it, but on the cross section upstream, it has the same cross section as what our riffle cross section would be, or our pool cross section, dependent on where we place the structure. And generally, these are going to be placed on the downstream side of a riffle. When I started in this field, I remember up until 2002, we had a real confusion on where cross vanes get placed in rivers. We were told as we were taking classes that a cross vane goes at the point of tangency, and then we were also told that a riffle goes at the point of tangency. So for a while, people in the field believed that a cross vane went at the head of the riffle because they both go at the point of tangency in the river. And that was not true, and it was never really actually intended to be true, but it was communicated by educators, and people didn't understand what was actually said. What is true, what really happens is if you have a riffle length that's an appropriate riffle length, then the riffle goes at the point of tangency. If you have a riffle length that's longer than your appropriate riffle length, you have a potential to put your cross vane in as well. Cross vane centralizes flows and pushes them downstream in a direction that does not help turn the flows at all. Therefore, it has to go in a tangent section. So that means that your cross vane will go in a point of tangency, but only in a point of tangency when there's room for a riffle on the downstream direction, or if we're trying to create a riffle pool sequence, step pool sequence, and we don't care about riffles. So if we want a riffle, essentially what we do is we create a pool with a cross vane, and then downstream in the tangent section, we have a riffle after we get past the scour associated with that cross vane. So it has changed how we look at these structures. So if we just look at a standard structure of cross vanes, we generally see a step pool formation. We don't see large riffles that are created. Now we can use step pools in a riffle pool sequence, but if we're using step pools in a riffle pool sequence, we have to have that elongated tangent section to be able to use both a cross vane and a riffle. So with these cross vanes, every cross vane design that I know of that's relevant right now calls for fabric behind these rocks. We don't have a cross vane design that I'm familiar with that doesn't call for fabric behind the rock. We call for a 4-ounce non-woven fabric. And that's kind of a little bit like a landscape fabric. So you're not going to look at it and see the threads in between it. It's not like silk fence where you can see the threads in between there, but it will allow, this fabric's allowed to get packed in between the rocks, and as material comes, as water gets pushed through the gaps in the rocks, it should catch sediment and then clog up the gaps in these structures. So that's one of the important opportunities to look at failure mechanisms, is sometimes if we have a gap in the fabric, or if we have a hole in the fabric, or the fabric ripped when we place it down, we'll see where rocks are kind of pulling through, where gravels are getting pulled through one rock, and that's just the potential that we had fabric that was misplaced. And sometimes we have seen people build these structures with no fabric, and sometimes they're successful, but a lot of times they are not successful as well. We look at the non-woven fabric behind all the boulders. We have a 25-degree arm angle on average, so it can be 20 to 30 degrees. So these are meant for grade control in a system. This is when we need a firm grade control. We can't depend on riffle materials upstream, and we have some sort of infrastructure concern. So this is a project where we, on the right bank looking upstream, which is the left bank, on the right side of this picture, we had a sewer line that we were protecting, and we didn't want to have the potential for grade control, for this to cut down anymore and have horizontal migration. And we also want to centralize the flow, so we kept everything moving straight past the sewer line. So this was the reason why we used this structure. A lot of times this uses more rock than some other structures, but it's a sturdy structure and it protects things. It also generally doesn't look as natural as a lot of other structures do, but it will give you a more firm grade control, more engineered grade control at times. And then this is a picture of the same structure. Everything that's matted on the right bank is where the sewer line is, and where we're trying to protect. So we can also embed logs into cross-vanes. It's really important, if we're trying to embed logs into cross-vanes, that we embed them below the footers, that we don't actually embed them into the header rock locations. We've seen a lot of people try to make these structures look nicer by adding wood to them, but they'll add wood into the header rocks, and then we see failures related to scour around the header rocks. So we need to set a good row of footers and headers on these structures, and then we can put whatever wood we want underneath the footers, and we can have them point up towards the water surface by using angles, but we don't want to compromise our footers or our headers by adding rocks into a Boulder cross-vane structure. So this is one, you can see the footers here, and you can see that log that's sticking out underneath the footer. So the footer is actually holding as a weight to cantilever that log, as well as serving as a splash rock for the headers and a footer rock for the headers. Here's a project that we did years ago in western North Carolina at Cane Creek, and North State constructed this one for us as well. And this is a Boulder cross-vane at a bridge for a bridge protection. And here, what we're trying to do is, we were starting to see migration towards this newly placed bridge. It's at a bad angle, but our idea was we could put in a cross-vane and would centralize the flows and keep the flows away from the abutments of the bridge. So one way that we analyze these structures is by looking at shear stress. So looking at the hydraulic geometry by stages, so looking at all the potential flows that could come down through a site, and then being able to plot what a shear stress you would have at different elevations and different discharges in the river. And then that will give us some sort of idea of, okay, well, what can we protect against? What will our shear stresses be? And that will help us with boulder sizing. So obviously slope has a big impact on this. A 12% slope or a 2% slope is going to mean a significantly different shear stress distribution for the same dimension channels. What we do in boulder sizing is, there's a lot of different ways that we can do boulder sizing. I have a reference down here from Gordon 2016, and then the NRCS guidebook in 2007 that talks about scour calculations that can be used for this. A lot of times what I do is I look at our critical dimensional shear stress for rock movement, and then I'll use a factor of safety on top of that, and I'll create a line on top of the Shields diagram and the Roskin diagram, and that will give me kind of my range of what I designed to. Now, a lot of times I only have one point on that line, but if I kind of follow the same trends of the other lines, then that gives me a way of sizing boulders to get started on these projects. So what that would mean is something like this. If I have 3 pounds per square foot for shear force, then I'm going to need a 1 meter diameter boulder approximately to be able to protect against that, or a 3 foot diameter boulder. The other thing is we have to look at what our scour depths are. This is a project that had failed in Texas, and when we started analyzing it, we realized that we had called for an 8 foot scour depth because the shear force is related to this, and we called for a 3 foot diameter boulder for the headers and the footers, and we ended up not getting either of them. So we actually surveyed this after it had failed, and it told us where our footer depths were, where our header depths were, and we started realizing that, okay, well, one of the issues here was we had rocks, boulders that were too small, but we couldn't see them from the surface after they were installed, and we didn't catch them during construction. And then we also had footer depths that were too shallow, so it wasn't getting protected against that. Here's a picture of that project. And this is, we also had the horizontal issues with how the structures were built. But you can see that we had small rocks that were level in these boulders, but they weren't really good footers. And we were looking for a 3 foot diameter boulder, and we end up not even seeing 3 feet in diameter in the scour depth, much less the boulder. So when looking at rocks that had moved on this example project, we ended up counting 7 rocks, and then later we went out and counted 10 more rocks, and out of those 17 rocks, we didn't find a single boulder that actually met the dimension of a 1 to 2 ton boulder with a minimum with an average dimension of 2.5 foot. So one of the things that we look at when we see structure failures and we start to see rock movements is this something related to scour, or is this something related to just the boulder size itself? So did we not predict the scour right, or did we not predict the boulder size right? And on this one, our details called for a 2 to 3 V-axis diameter boulder, or if we're using a concrete block, because they were allowed to use recycled concrete on this project, a 3 foot minimum B-axis. And they all had to be 1 to 2 ton. So in looking at potential failures, it's important for us to understand, okay, are we losing headers because they're sinking into fine sands? Are we losing the headers because they're sliding off? Or are we flanking structures? Is there something where we cut around the structure? And that's been the reason for it. And if we did cut around it, was it because we didn't have fabric? Was it because we had rocks that were too small? So here's a project that we worked on with EBX years ago and Dave Godley. And this was in Morgan Creek in western North Carolina. And this is a project where they built a whole bunch of cross-vanes. But we were talking at this time, it was mid-2000s, and in the mid-2000s, people were trying to figure out where to put cross-vanes, and a lot of times people would put a cross-vane at the end of a riffle because they knew it was going to create a pool, but yet they figured they'd just put it at the end of the riffle. Well, what happened in a lot of these situations is because they were at the end of the riffle, water tried to turn, and we ended up flanking these structures. So we were trying to turn water, but yet it just flanked the structure because the flows of the channel were trying to turn while the structure was trying to make it go straight. We also had where, on this example, you can see that there's only one boulder in the sill here. So the sill did not go that far into the channel, but what we can see for flanking is essentially when the water goes around the structure. And when the water goes around the structure, it neither holds grade, and then it also creates severe erosion associated with it. And that can be related to the fact that you don't have good fabric. It could be that you didn't have a good sill length, or that the structure was just placed in the wrong direction. Here's a location we had flanking and degradation due to the boulder size movement. This was the same project I'd shown you before. And we just documented that our 1 to 2 ton boulders, most of the boulders that had moved from this location, we couldn't tell if they were there before or not because they moved. But if we look at the pile of boulders down below there, our average boulder size down there was a 700-pound boulder. So we needed a 1 to 2 ton boulder. So maybe we could get away with 2,000 pounds, but we really wanted something closer to 3,000 pounds, or even 4,000. And we ended up getting a 700-pound boulder. So, we do have flanking when we lose rocks. If there's a little bit of a gap in the sills and they're too small of rocks, well, then we can basically eat around these structures, and then the whole flow path goes around there. So if we look where the flow path is in this picture, that was just due to flanking around this structure. And then we can also put in a structure that's too high with a cross-vane. And because we fill in the gaps of the cross-vane, we try to transport the sediment through the center of the structure, but they can get filled in pretty quickly. So if we put them too high, and we have a high bed load system. This is Brandon Roskin and I were surveying the Bitterroot River back in 2008. And this is a structure that somebody else had built that they put in too high, and the gaps just were clogged up with a high bed load material. And essentially what happened is it graded everything upstream, and then the river cut a half a mile to the left. And of course, people lost their irrigation diversions, and they weren't very happy with the projects. They used to have riverfront property. The guy that owned this property was one of the head guys at Charles Schwab, the investment firm. So he wasn't very happy that he now didn't have a river next to his house or close to his house to fish, and that he put in all his habitat money, and the whole river revulsed and moved a half mile towards the west. So we see a lot of failure mechanisms with these structures. It doesn't mean that these structures aren't good. These structures are great structures, but we don't put in a cross-vane in a place where we don't have an extended length of a riffle. So if we have a riffle that's 5 times the bankful width, we have room for a cross-vane. If we have a riffle that's 3 times, or a tangent section that's 3 times the bankful width, we don't have a room for a cross-vane. We put in cross-vanes a lot of times when we have to connect back to the channel. In 2008 and 2009, I started using a rule of thumb saying that I don't build cross-vanes in channels less than 40 feet wide, because generally we don't have room for them. They don't fit too nicely. And I have varied from that sometimes, but it's still a rule of thumb that I kind of think of is on smaller channels less than 40 feet wide, a lot of times I just don't use cross-vanes. We don't have a need for them, so we won't install them. We'll use other grade control methods. Cross-vanes move towards a step pull system almost always. If you don't have a long enough riffle length, you're going to lose riffle production. So when it comes to habitat, these cross-vanes have been increed on the Rio Grande River. The Colorado Parks and Wildlife has been testing habitat suitability and biomass associated with different structures. And what they found is the vortex weirs and cross-vanes have less biomass associated with a river length of that structure than a boulder constructed riffle with pocket pools with smaller pools. So you may get a big deep pool, but you're actually not getting much production out of that big deep pool because you're losing riffle habitat, you're losing spawn habitat as well. So a cross-vane is a good structure if you need a big sturdy structure, but it's a structure that we use sparingly now compared to what we used 10, 15 years ago. Additional papers, Dave Roskin published the first paper on a cross-vane in 2001 with the American Society of Civil Engineers. Paige Puckett and Barbara Dahl did some really neat research on cross-vanes, a comprehensive study of in-stream structures, and she talked about failure mechanisms of cross-vanes and value of the cross-vanes. Part of that research was related to benthos research that Dave Penrose and Desiree Tolas had done in Desiree's PhD research as well. And then what I copied today with the email reminder was a paper authored by Hickman and Tetz Thompson at Virginia Tech, where they talk about stream restoration series, and it's basically cross-vane structures. So they talk about cross-vane structures. So those are a couple thoughts. Things for us to discuss. If you want, RiverShare is looking to create a detail repository where people can go in there and get a detail and look at different details. A lot of that information comes from Stantec, SWCA, RES, WWC, and other people that have shared details. one of the things that we're going to be looking for is people to kind of have critical review of the details as we make them available to other people. And then also, if you want to share details, a place that you can say, hey, this is a detail I really liked, and we incorporate that into every structure. The restoration of these projects isn't related to the structures. It's related to the change in dimension, pattern, profile for the sediment and the water being supplied in the system. But structures help us get there and can provide function and habitat at times. So those are some thoughts related to Boulder cross-vanes. I don't know if anybody else has anything they want to add or comments or concerns. I don't particularly have the energy to do a structure a week for the next, until we're done. So I'm probably going to work in a structure a month because I find these very boring to me. I mean, I think there's value in them. And if there's anything else that somebody wants to do for a structure a month, like Josh, if there's a structure that you've really liked working on, if you want to kind of follow this format, if you want to present on it one week and failure mechanisms, I think that would be valuable to the team. Or if Greg or Tim, you guys have structures that you like to do, or Rich, if there's a structure that you really have appreciated building that you want to kind of talk about, then we'll probably do that. So I'm thinking that we'll probably do, just by chance, since this is the second Monday of the month, we'll just do the second Monday of the month where we'll talk about a structure opposed to doing, we essentially we'll be doing structures for a long time if I don't do it that way, and that would be boring for me. So.
Hey Dave, I know a lot of people have started using these as in stormwater channels. Have you done that much or seen failures when used as kind of step pool stormwater type structures?
Yeah, you mean related to things like regenerative stormwater design, or in North Carolina they're calling it
even outfall.
For an outfall?
Even outfalls, yeah.
Yeah.
I think, Tim.
Yeah, I've actually, they've been pretty successful. The only issues that I've seen with outfalls, and we've done them a lot on outfalls, is when we've tried to turn the flows quickly after that. For outfall design, a lot of times when I look at for one of these structures is I look at a standard Maryland Highway Department preform scour pool design in association with a Boulder cross-vane, and then I'll put one of these preformed scour pools downstream of every outfall if I can fit it in, and that's related to the drop height on the cross-vane as well, and that's worked out pretty well for us. I have seen some failures related to cross-vanes on outfall designs, but usually it's because people are taking too big of a drop or trying to turn the flows too quickly afterwards. And I don't know, Josh and Tim, you've probably been through the point where we go downstream with some sort of a structure and then we create a meandering pattern quickly. That's something where we really backed away from, and we basically come out of confinements with very gradual meander patterns and transitions, and we look at these preformed scour pools in conjunction with the reference reach design that we're doing, so we can't really just use one. And that's kind of what I'm saying here. So.
Yeah, I've definitely noticed the issues with trying to have the meanders too soon, and even with J hooks or any structure that's turning water like that, it doesn't seem like people give near enough room for that to fully take effect and let things dissipate enough to start the meander pattern again.
I made a comment earlier about seeing many double drops lately, and the double drops and the cross-vane. Some folks have branded themselves in their design methodology of just forcing the channel, not even a threshold design, just more of a controlled design. And I've seen cross-vanes used out in Texas and other places, just as, like you said, Tim, it's found its way into the stormwater toolbox. And as the as the engineers from the human environment encounter us coming up from the natural environment and that end of pipe treatment, ruminated the stormwater treatment. So yeah, I use them sparingly too, Dave, and Tim, when I apply a similar concept on a usually I don't call it a cross-vane, even though it has some of those elements. Try to call it something different.
Yeah, and I've done the same thing too, Josh, where a lot of times we'll get a structure that we have to adjust for one reason or another from a cross-vane. And we'll even get to a point where we just call it really generic names like stormwater grade control or something. I mean, sometimes it's better not to call it a cross-vane if you have to adjust it, because then people don't get as excited about it. So. All right. Well, thanks a lot, guys. Have a wonderful week. If any of you want to talk about a structure next month, shoot me an email and tell me, and I'd be happy not to talk about another structure next month. But I will if we don't go this way. I'll probably move towards the J hook next, and then on from there, constructed riffle. But if you have an idea of something you want to talk about related to structure, give me an email and I'll let you talk about it. So.
Hey, Dave, talk to you about Elmore for a minute.
Okay.
Let me just pull something up here. On Zone 1, Reach 4, priority 2 restoration is what you put in the narrative.
Right.
And when I call it up, let me just see. Sorry, I've got 1,000 screens open here and I'm trying to get to the right thing. If you can let me share.
Yep. Go ahead.
Okay. Let me go down to. This is Zone 1 to Reach 4, and you call this priority 2 restoration, and we drew it in at the right elevation, and it doesn't look like it's really priority 2. Now, it may be where we cut the cross section. I'm not sure.
Yeah, it's just where we cut the cross section. If we move it upstream, it'll look like priority 2. This is because of how wide it is and stuff. If we extended the cross section, you'd be able to see a lot better too. But probably just moving the cross section. I can't tell where it is on section 4. I think it's down near the time. Yeah.
This is where the bridge is, and you have the alignment drawn way different than where the bridge is.
Correct.
So, I mean, if you have the alignment off of where the bridge is, how is it priority 2 restoration?
We move alignment for priority 2 restoration.
Okay. Well, I'll see if I can find it.
So you're saying, Dave, if we went upstream, we'd find we'd be cutting a floodplain then?
Yeah, let me bring it up quick.
Okay.
I'll see. I imagine I still have it up. Generally, we don't adjust since we just rename files. So I know I actually had this one laid out.
Anyway, everything else is fine, Dave. All the other cross sections are working fine, but this one just didn't make a lot of sense because basically you'd called it priority 2. So for the client, I was trying to help them understand. So I changed the name to cut a new floodplain for the existing channel just to try and help them understand it. But then when I looked at this doesn't look like cutting a floodplain. This looks like adding fill to, bring it up.
Yeah, let me.
I'll stop sharing so you can share, Dave. Thanks for jumping in. So, Dave, were you actually able to see the sky for all the smoke last night?
Oh yeah, it was great. There's not much smoke right now because the fire's kind of died down a little bit. I mean, it's
Okay.
not contained yet, but we were able to see everything really nicely.
I see a bunch of boxes of Dr. Pepper in the background, Dave. It looks like you've taken up a bad old habit again.
It does. It is. Yeah, that's exactly what it is.
Andrea, did you get my comment on the Reach 3A? You understood what I was getting at?
I didn't understand what you were getting at. No.
You didn't. Oh, basically just we show cutting a bench on the left bank and there's no bench because basically we can't get access to it. So it needs to just go straight up the red line.
You just want the red line to go straight up?
Well, basically not to show a bench.
Okay. That's
So
the inner
basically-
berm.
Well, okay, whatever. I wasn't sure what I was sorry. I was just trying to throw it at you. Yeah.
Yeah, I can do that. Just make that
So
line go straight.
Yeah, basically, we're not going to have a way to get over there, so I just want to take that treatment out of there. So I would basically just angle it up so that it connects up at the top. Basically, it should tie in right away is what it should do. Actually, let me go back and look at that cross section.
And we can just remove that red line and just have it tie in.
I'm just going there right now. 3A. Yeah.
All right. I'm ready to share
Skip
then if you're ready.
Yeah, tie it in and skip the inner berm. Anyway, go ahead, Dave.
All right. So this is if you can see my split screen right now, this is
Yep.
this is that reach we're looking at, and this is where the bridge is at right there. So if I pull a cross section, you can see it shows as a pretty good priority 2 there.
Okay, so you're
Restoration.
moving, you're cutting that loop out where the bridge is.
Correct. Yep.
Got it. Okay. Andrea, does that
Now,
work?
I can, yeah, that's no problem.
Okay.
I don't know if you want to show this or not.
No, I'm just showing cross sections
show-
to help them understand, Dave.
Yeah, that's kind of what I figured. I figured we don't need to show the old one, so we'll just do that, and that should be fine. So, and Andrea, that's still in that concept 909-2020.
Just save it and
And I
it'll
think-
update it automatically.
That sounds awesome. So, all right. Well, very good. So we'll get that one taken care of.
So if we can fix that in 3A, Andrea, and resend those to me, then we're golden. Thank you so much.
Yeah, you can do that.
Awesome. Thanks.
Well, Golden's pretty good.
Yeah, no, it's pretty good. Dave, I was up on Labor Day, but I didn't see an invite for that morning. So you did it on the Monday?
Yeah, we did it. We did it for Monday. I didn't invite anybody because I figured if people were spending time with their own family, I wasn't gonna. I just figured I'd let the return invite go out. But
Well, I came into the office to do it and there was nothing there. So I figured you were going to do it Tuesday, and then I logged in on Tuesday and there was nothing there on Tuesday. So then I figured we skipped it. So I'm sorry. I would have participated.
oh, that's okay. Yeah,
You
I was
know,
actually kind of surprised. I was surprised you didn't because I figured you didn't care much about Labor Day.
Why is that?
Well, because I mean, it's not a holiday for you guys.
Yeah, it is.
So Labor Day is a holiday for you too.
Absolutely.
I did not know that.
It's
You
one
just
of,
spelled
turn,
differently.
turn your calendar on for Canadian holidays. It's one of the ones that actually overlaps with the States. A lot of those
Oh,
a little bit, but Labor Day is actually, no, it's a holiday, man. That's how you know it's Labor Day, because we always start school the day after Labor Day.
oh, that's good.
No,
I
thought you meant I wasn't. I thought you meant I wasn't paying any attention because I was working, because I'm self-employed and I don't get paid holidays anymore. But no, it was
Well, that too.
yeah, that too. Anyway, yeah, sorry we spell it funny, but you know, that's just the way it goes. You guys,
Yeah, we kept it pretty simple last week. Basically, I just called in, and if anybody was there, then we talked, and then that's when only 2 people were on there, which is Philip and Kennard, and so we went over. I forget what we went over for the talk, but then Kennard said he'd really like to see us do structure comparison.
And
structure.
Dave, I know you think it's boring, but I actually really enjoyed the talk again today, because I'd love to. But
I'm hoping that Tim or Mike or
somebody will help
Josh
you.
or somebody else will do one of these structures. I mean, I don't mind doing them every week. They're just not as exciting for me because, it's just been doing it for a while. I like to hear other people's thoughts about things too.
Yeah,
So.
yeah. I'd like to get you doing these, was that one recorded, Dave, today?
Yeah, they're all recorded. So you can share them with whoever. We're gonna get them. Right now they're only on Dropbox, but that's what Sarah's tasks are, to get them all into place where Trimming can just link them to the website and stuff.
Yeah, Dave, can you send me the recording for, just a second? Because I want to send it to DFO and I wanted to say, here's the kind of thing that we can do for you. So if you could send me the copy of that, then that would be great.
Yeah, and what we have Sarah, I'll do it today. But what
Okay.
we have Sarah doing is separating all the presentations. So you'll have a technical and you'll have an inspirational presentation on each, and then separating all the videos as well. That way, if somebody really is offended and doesn't want to have to page through all the things before it, they don't have to. They can just go straight to the technical stuff.
Okay. Andrea, are you okay then? You can go ahead and make those two changes for 3A and the one in zone 1 reach 4?
I think she's just about got it knocked out.
Oh, okay, then good. Then I'll go away. I haven't had any breakfast yet, so I'm starting to get growly. So, thank you, Greg. How was the birthday party? I asked, did you have like sparklers and cool stuff?
Oh, just cool stuff. No sparklers. Did some ice cream sandwiches and had some friends
Oh.
over Friday night. And my parents were up Saturday.
Cool.
It was good.
I think you should have had sparklers.
We should have. Oh
Keep
no,
that
they're a
in
little
mind.
little timid with the fire thing up here in Larimer County.
Come on, man. Do it inside the house then.
There you go.
You can set the curtains on fire.
Wow.
I did try to set a rag on fire right before the party on Friday. So
Oh, good.
tried.
Hey, Dave, I sent Abby an email on Thursday asking her if she could total up the expenses on the regional curve. So I can bill so we can tell Wiregrass. I'm going to try and get pay half. Can you check and see if she's going to be able to get that to me in a day or so?
Yeah, I'll see if I might be able to do it too. I just have to log on to.
Okay, whenever. Just if you can figure it out, what was billed to that, that'd be great. Because I'd like to get Elmore a check for, I think we spent I'm guessing about 35-ish. It was pretty cost effective because Ryan did a lot of it. So.
Yeah.
But anyway, so yeah. If you
I'm checking, and that's just for the regional curve. So
just the regional curve. Okay.
Yeah, I should be able to find it on QuickBooks.
Okay.
I don't know
Well,
how
I'll
to
let you
use it,
go,
but-
guys. I don't need to keep you. Thanks, Andrew.
Hey, Greg and Andrea,
Yeah.
one last thing before we go.
Go ahead.
We're thinking about leaving, trying to get up to South Dakota by noon on Friday. Does that work for you?
Yeah, that'll work. We've got we were actually thinking about leaving. Well, I guess if you guys are leaving Friday, we'll just leave Friday with you. But yeah,
What time
anytime
are you
after
thinking about leaving?
about noon on Thursday would be fine.
Yeah, Thursday night we'll be. Thursday night, I think we're going to be staying in Laramie for the night, but we might go up Thursday night too. I have a couple of tasks I'm doing Thursday morning, so maybe we'll just get going on Thursday night.
Okay.
We were gonna. You're taking Sarah, right?
We're debating.
Okay.
So if you probably
we were going to get a
motivate-
place to take. We were going to get a place that takes dogs anyways, just because we were going to be taking Laz with us.
Are you
Well,
guys planning on camping still? Or are you gonna get a hotel?
I think we're going to get a hotel. Our stuff's not going to fit too well. Are you guys planning on camping in a hotel?
We're planning on a hotel. I think the girls love
Yeah,
some
then-
pool time.
Yeah, that's kind of what I thought too. So do you have a preference, or if we book 2 rooms, are you cool with it and we'll just give you 1 room?
Yeah, no, we're cool. Whatever.
That way you don't even have to worry about the expenses. We'll just kind of get it covered.
Nice.
I think we're going to stay at we were looking at the DoubleTree in Deadwood, South Dakota, which is about 15 minutes away. But it looked like it would be more fun for the kids with swimming and stuff, and they take dogs. So.
Awesome. Yeah, we're gonna think about Sarah. We're not sure if she wants to ride along or not, but
And then we were looking at leaving on probably sometime Sunday afternoon.
Yeah.
Does that work for you guys? Okay, cool.
yep, I think that was
So
about
we'll
our
just-
plan too.
Good. We'll get it for Friday and Saturday nights, and then we'll be headed to Idaho on Sunday, and you'll be headed home. So.
Nice. That sounds like fun. We're looking forward to it.
Yeah, we are too. Especially when I say we, especially Ida. But all right, we'll talk to you soon. Thanks, guys.
Yep. Thank you. Talk to you later.